Question 5.33. This question is not an easy one and requires putting together material from chapters blah blah blah. Suppose we take up a driving test and we have a good reason to believe that 60% of the drivers should pass. Okay, that is the probability of the event happening is 60%. So they have 30 drivers and 22 pass. Okay, and if you divide 22 by 30, you get like 73%. So that's different than the 60%. But now we got to figure out, is that enough reason to reject the null hypothesis that the probability that the event will happen is 0.60, okay? So this is a hard one, and I'm going to show you with a graph on how to do this one. So please hold. This is a binomial distribution problem. Okay, let's go back to his handouts and find binomial. Binomials down here somewhere. I just look at the formulas. There it is right there. Okay, so we're going to use this information to calculate our mean and our variance and standard deviation. The only reason we're calculating the variance, of course you all know this, is to calculate the standard deviation because we're going to need it. Let's go back to our drawing here. So we're going to do this by a graph, and you guys should all know this by now, but you know, the main graph in statistics is this bad boy, right? It's the normal distribution curve. But what we got to do is we got to figure out what the binomial mean is and the binomial standard deviations using those two formulas that he gave us here, right? The mean is n times p, the variance is n times p times q, and the standard deviation is the square root of that mess. And the same thing, capital N is the sample size, and little p is the probability of the event happening, which is stated as 0.6, and q is the probability that the event will not happen, which is 1 minus 0.6, which is 0.4. Okay, so we got those down there, right? 30 is the sample size from the problem. 0.6 is, again, is the null we're testing, and the event, the probability the event won't happen is 0.4. So we're just going to plug and we're going to chug. So we're going to calculate the binomial mean. So it's 30 times 0.6, right? Say that again. N is 30, P is 0.6. Multiply them out, we get 18. So 18 is the mean. Let's put that on our normal distribution graph down here. It goes right at where the z-score is 0, right? That is the mean. Now let's figure out the standard deviation. We're going to use that formula right there. Again, n is 30. The little p is 0.6. Little q is 0.4. Multiply them out. So we're going to take the square root of 7.2, and we get 2.68. So we're going to add these. These are real numbers, right? They're not z-scores. These are real numbers. I'm going to add that to 18. So 20.68 is one standard deviation from the mean, above the mean. And I added another 2.68 to 20.68. That's two standard deviations to the mean, above the mean. And then going the other way, I subtracted 2.68 from 18, and I subtracted another 2.68 from 15.32. So these numbers represent how many standard deviations away from the mean they are, the binomial mean, okay? So we got to remember that a 95% confidence interval basically states this, that 95% of the data is between the mean plus or minus 2 standard deviations. I got that from the empirical rule. Now he might be using 1.96 instead of 2, but you know, it's so darn close that the difference is minimal. But now we got to figure out what the okay range is with the 95%. So we're gonna figure out where the mean plus 2 standard deviations is, which is right here, and the mean minus 2 standard deviations, which is down here. Okay, and we gotta determine, is 22 within that interval. So again, the 95% rule, confidence interval, states that the mean will fall between these two ranges. So where does 22 fit in here? It fits in right there, right between 20.68 and 23.36. So it is within the range. It is in the okay zone. So therefore, since the 22 is in the confidence interval, you cannot reject the null. I'll say that again. Because 22 is within the confidence interval, you cannot reject the null. So that's it. Hope this helps. MGZ, out.